Yo, what's up guys, this is your boy Amritans, and in this video I'm gonna make this spinning cube in the JS. Okay, so it is very interesting thing. Ignore the file's name, I was actually testing. So okay, we are gonna do this. So let's run this, and it looks very good. Okay. Oh, I make the mistake, but okay, yeah. See, so we are gonna create this. I'm gonna give you every single logic how it is working, and by the end of this video you're gonna understand every single piece. So yeah, watch the video till end. Till then, peace. Let's go. Watch till now. And see, this is a cube only. Okay, I'm gonna zoom it. See, a proper cube. Yeah, so let's go. So the idea of this spinning thing. So the idea of this spinning cube has come from this donut one, which was I think written in C. So if you see here and you think that it is very easy, then but do not worry, your brother is there, and I'm gonna teach you everything how this thing work. I know it looks hard, but we are not gonna understand this deep. Okay, but yeah. So let's start the video. Let's go. So yeah, there would be a question in your mind, like why we will learn this. Okay, and by the end of this video you will understand what is x y z axis in 3D. Okay, then you will also understand the how a cube is made with points, why we need loops to fill faces, then how rotation works using sin and cos, then how we project 3D points on a on a flat screen, and how perspective work and why it looks solid. But why we need to learn this? See, understanding 3D points, loops and rotation is the foundation, okay, of a video game. The video game is made by using these concepts only, and knowing this math, the math in this video of course will allow you to create a realistic movement in virtual world. Because remember, this screen is flat, not 3D. Okay, but you feel 3D because of these things only. So uh, first of all we will go, let's go to what is a 3D space. Yeah, sorry, what is a 3D space? Okay, what is a 3D space? We will understand this thing. So first we will understand the 3D space. Okay, so in a school we all have learn about graphs. So in graphs what we see? We see a x-axis and a y-axis. This is the y-axis, and this is the x-axis. Okay, in the school we see this thing only. This is x and this is y. But in the 3D world, one more axis is added, which is forward and backward. So if you see this axis, forward and backward, okay, this is up down, left right, and forward backward, which is a z axis. So in physics or in math we make diagram like this. Okay, x zy, exactly like this. We will understand this thing with an example of our cube. Okay, so if this cube is moving like this in this motion, we will understand this with the example of a cube. So if the cube is moving like this, I hope that it is clear, like this, it is y yeah, x-axis, and like this, up down, up down, up down, up down, up down is y-axis, and forward backward, forward backward, forward backward, this is z-axis. So every sticker we can say, or point is we can say, is written in the form of xyz. So for example, this center point would be 0 0, sorry, drawing is not good, 0. Okay, this center point. Now the back to that, and like we move, each point is some point of and the points are xyz. Okay, so like this only. If front top left, if we do front, this is from my side, my perspective. Now from here, this front top, front front top, okay, front top left, front top left, this point is would be -1 -1 -1, like that. Every point on a cube is represented by xyz. Okay, so yeah, that's the thing. And for example, let's go to now our screen. So I am on my screen now, and we have know what is axis now. You have understand the 3D space. This is how it works. You just need this much thing, then we will move to our code also, but for first we need to understand. So yeah, this thing is all done. Now what we will understand, building points, building a cube with points. See, in our this thing, the cube is built by a point, and the point is like characters, different character, dollar sign, like this, but they all are a point. If you see clearly, the cube are built by taking point. And in a flip book, remember, this thing is printing in the way of flip book, which we have used in our childhood. So like that only. So in a point it is printing. Okay, in a point, by the point it is printing. Okay, sorry, yes, by the point it is printing. In our code, if we will go to this function, yeah, okay, these two functions. Okay, so what this function is doing, I is horizontally horizontal movement on a face. Okay, at a point we will show one face on the cube. Okay, so I is basically the horizontal points or the horizontal movement on the face, and Z is the vertical movement on the face. Think of it like scanning a wall with a pen. Okay, you start from top left and fill every row of dots to the bottom right. So even if like the cube stays in one place, these loops are needed so that the faces of cube looks solid. If we skip these points, okay, if we are not gonna fill the point, the cube, we will only have 8 points. Okay, and the cube will look hollow from inside like a skeleton. Okay, so that's why these are important to, they are basically filling the points. And remember this thing. Okay, this is a short thing which I want to explain. This faces and axis. Okay, faces and fixed axis. If you are showing one axis on a screen, if you are showing one face, one side of a face on a screen, in that one axis would be fixed and two will be on a moving side. Okay, so for example, if you are showing the front face of a front face, if you are showing the front face of a cube, if you are showing a front face of a cube, okay, if you are showing front face of a cube, the z-axis would be fixed, and in the like x and y would be on moving side. Same on the back side, z would be fixed, but it would be positive. At front it is negative z, it is then back positive. On the left side, if you are going, then the fixed axis would be x on the left side, right side also x on the top and bottom y. Okay, and it is positive, negative, we all know that thing. Now why one axis is fixed? Okay, any reason? Because a flat face only moves in two directions. If we changed all three directions, then we would fill the entire volume, not just the face. So that's why. So now let's go to our Rubik's Cube example, and I will show you that thing. Let's go. So yeah, this is my cube, and now what I'm gonna tell you this, like, for example, I have tell you that one axis would be always fixed. For example, this is top stickers. Okay, let's take the example of this top stickers. As you can see, let's take this side. So this top stickers, if I move it, you notice one thing, y-axis is fixed. Y-axis is fixed. It is either going forward, backward, left, right. That's it. And if you gonna do with whole cube also, then it is rotating like this one. So it is going forward and backward. It will go forward, backward. It will not go like this from the top stickers. Okay, so y is fixed. So this is the example in the, I'm using this cube so you will get the example in real life also, you understand it properly. So yeah, this is the thing, and now I'm gonna draw a diagram. Okay, so let's draw a diagram. Let's go. So I am here now. I will draw a diagram. So for example, let's say, for example, I'm gonna take that. Okay, for example, this is not 3D space, this is the wrong topic, so you know that. For example, if a cube length is 8, if a cube length is 8, how we will draw it? Okay, if the cube length is 8, so I'm gonna take a line from here and from here. Okay, this is our cube length. Okay, wait a minute. Okay, so like, yeah, so here what it would be, there would be number 1 2 3 4 5 6 7 8, and 1 2 3 4 5 6 and 8, 6 7 8. And remember, sorry, we are not gonna make 8, we are gonna make -8 to +8. For example, a cube length is 8. For example, a cube length is 8. How we will draw it? We will draw in the real life, it would be like this thing. Exactly. Wait a minute. In real life, it would be like this. This. Then this. Then this. And what would be the length? It would be 8 to -8. Yeah, so like that only. This would be -8, this would be -8, one line, this would be +8, -8, and there the length would be form. Okay, this would be form, which would be square would be form, and the length would be 8. Okay, -8 to +8, because two axes are there, we know that. Okay, every axis has two things, positive and negative. So but in screen we show only two axes. So for that two axes we are gonna draw something like this. Okay, for that two axis, this line, for here, then we will draw, after we draw that line, we will draw some points. Okay, and this point would be -8 to +8. Here would be -8 to +8, -8 to +8, every point. And for example, a particular point on this graph would have like -1 4, like this. There would be coordinates to draw that point, and we will get that coordinate also. Okay, so for drawing each point, we will need to give the computer the coordinates so they can draw the point. And remember, in this program I function I is for horizontal, this is for vertical. Okay, and I'm gonna give you the diagram PDF in the background, so from there you can do that. And this is exactly what our code is doing, this thing, this part, exactly what it is doing. Okay, this giving coordinates, so we can draw the line. Now we will move on to our one of the most important topic in this, which is uh, why no no what before that we are gonna move to one question which many people asked, that why loops are needed if the cube only spin. Okay, why we are drawing faces? Because this part is for movement, okay, but we are doing rotation, so why we are drawing faces? Okay, but so like yes, the cube will stay in one place only when it is rotating. The cube will be in one place only. Okay, this would be in one place only, but the loops are used to fill the sticker, or we can say fill the dots on the face, make it look solid and give a rotation something to act on it. Okay, so rotation spin all these points. Okay, rotation spin all these points together, that's it. Okay, that's the thing which we are going to talk now. What is now of course one of the most important part is understanding rotation. Okay, it is one of the most important part in this thing, and understanding rotation, yeah, it is very important thing, very important topic. So I'm gonna go a little brief on it. Okay, not little brief, mainly this topic I'm gonna explain in brief. So yeah, let's go and open our new page. Okay, this is a proper new page. Now for rotation we first I'm gonna open the code. This is our code. Okay, and the for rotation, where is the rotation part? Yeah, here we use cos and sin. Okay, we use cos, theta and sin, not theta, cos and sin. This is the most important point. This function will take coordinates of xyz. Okay, and it will return x is x2, y1 and z2, something like that. Okay, now we are gonna understand this function. Okay, what this function is doing. So basically what it is doing, that angle x, what is the meaning of, first we are gonna understand the meaning of angle x, which we are giving rotation around x-axis, and angle y rotation around y-axis. And remember, rotation around axis is rotation around y-axis. What do I mean? I'm gonna use again this Rubik's cube example to show you that. Okay, so yeah, I'm gonna use that, but for example later. Wait a minute, first I will explain this thing. Okay, so what, see, for rotation around x-axis only z and y will change. X would be remain same, in the formula would be y1 is equal to y cos minus z sin, and z1 is equal to y sin plus y cos. And I have not remember this formula. Okay, I have written in paper, that's why I'm saying I'm not a mathematics genius. That's the thing. Okay, so that, and it will return a rotated point. Okay, these are the rotated point which we have to show. Okay, these are the rotated points, okay, which we need to show. Okay, so but yeah, that's the thing. Now why we use sin and cos? So sin and cos allow us to move like points in a circular path around an axis. Okay, for example if for example I'm gonna take a Rubik's cube. Okay, first let's go to our Rubik's cube thing. So yeah, I am here. This is the Rubik's cube. For example, this is the, for example I'm saying, just take it, this is our y-axis, this is our z-axis, this is back and forth. Okay, so when the cube is rotating, remember, okay, it fits, man. When cube is rotating around x-axis, see what is changing. Points are going up, forward and upward, backward and downward. You are seeing this thing? Okay, you are seeing this thing. Wait a minute. Let's zoom this thing. Okay. Now you would be able to see what you are saying. The points, each points are moving upward, downward, forward and backward around the x-axis. Okay, x is fixed. Now around y-axis, points are moving left, right and forward, backward. See this point, forward, left, right, like this it is rotating. Okay, this is rotating. So but you have seen, but why we need wait a minute. So why we need sin and cos? See, sin and cos allow us to move the point in like a circular path. Okay, so I have already told you that, and I have taken the Rubik's cube example also. Without sin and cos, rotation wouldn't work. Okay, point would just jump into a new position instead of spinning smoothly. Think of a Ferris wheel or a giant wheel in your language. Okay, this is our giant wheel. Okay, this is our giant wheel. Okay, this is our giant wheel. Okay, so how it is working, if you wanna see it, each cabin each cabin moves in a perfect circle, like this, the center of a wheel is like origin, which would be 0 0, coordinate would be 0 and 0, and the sin and cos calculates the exact x and y position at each angle. Okay, you are getting this? That's exactly like what happens when we spin the cube stickers. They follow a circular path, and for example this cabin, you will understand this thing from this thing only. This cabin is moving downward, as you can see. This cabin is moving downward, then upward, and also left, right. So it would be like xy thing is there. Okay, at each point there would be coordinates, and coordinates are the most important thing. If you don't know the coordinate of anything, you can go to anything, man. Coordinates are just amazing thing. Okay, so that is what I'm telling you. Okay, each cabin. Okay, that's the thing, and I hope that you understand this thing. Now I will off my video. Okay, yeah. Okay, the video is off now because I don't want to show my face that much. Okay, and if you are enjoying, please subscribe. Okay, now guys, no, see, we are on the most important part now. Okay, we are on the most important thing. Okay guys, now we are on the most important thing, which is projecting a 3D into 2D. Okay, projecting a 3D into 2D, and here I'm gonna take a diagram. Okay, and this diagram is same as the donut CC, because see, I have not, this code is not originated by me. Okay, I have seen the code of cube 1. I have already seen the code of donut 1. This is not something invented by me. I have just transformed that thing in JavaScript, and anyone can do that. And I'm just understanding that thing, okay, and explaining you. I have not invented this code, not anything like that. First, I thought that I should make a banana, so that was the thing I was practicing. Okay, that was a thing I was practicing. Okay, and that was a thing which I was practicing, banana one, but it failed. Okay, leave. So what, see this diagram? Okay, now what is this diagram? Okay, we are gonna take your popcorn. This is, I'm gonna tell you very clearly what it is. See, if sorry, there is a window in front of you. Okay, there is a window in front of you, and from that window you are able to see one tree. From that window you are able to see one tree. For example, this is the tree. Okay, for perspective thing I'm saying. Okay, from the window you are able to see the tree, but the tree size or the XYZ for you would be the tree on the screen. The actual XYZ you will not able to find unless you go out and see the real tree. The formation of tree on this transparent window is just a smaller version of this original object. Okay, just a smaller version of an original object, and it would be dependent on Z. That Z will decide how far the object, how big the object should look. Okay, if it is far it will look small, if it is close it will look big. This is the basic mathematics. Okay, so this is the basic, and this we are doing that thing over here only. Okay, so in our code also, if you, we will go to our code. In our code also, see, this is our screen. No, not this one, scale one I am finding. Wait a minute. See. Now this is our thing which like a point far for this. Basically this is it, this is the diagram. Okay, this is basically what I'm saying in the form of code. So this will, I will explain in the code part, but now the main explanation. Point far away is smaller, point near is bigger. Okay, example, if you hold something, put move it away from yourself, you will say it is smaller, and when you move it more closer, it would look big. So for example, if you move anything away from you, it will look smaller, and more closer it will look bigger. This is decided by Z. Okay, Z. In this thing also, see, this is our main tree. Okay, this is our tree. The ray is forming, the ray, we all know the ray is coming like this one into our eye. This is our window, this is our real XYZ, and this is x1, y1, and z1. The distance from you to the window would be z1, and the distance from window to the tree would be the z, and this whole is a ray. Okay, and as you can see, it is smaller, it is y, the height is y. Okay, so this looks smaller. Okay, so that is basically the thing, perspective thing, which we need to implement our 3D, the 3D things. Okay, so it will look good, and we would able to do that thing. Okay, this is the basic diagram. Okay, this is the more basic, very easy diagram, which I hope that you have understand now. And yeah, this is basically the thing, and yeah, this is how the perspective works. But one more thing I wanna say you, that this is not related to this one. Okay, now we move from this topic away. Okay, sorry, my grammar is not good. Now we are moving from this topic. For example, there is one I'm doing it fast. mode. For example, there is this square which we are drawing, cube which we are drawing on the screen, and this is made up of points. This is made up of points, but still it looks solid. Why? Uh, because like we fill the point in just a way with our that thing for and for loop, that I and j1. So yeah, that's the thing which I'm gonna tell you, because when it loop fills the faces, then it will rotate, spin it, it will then project, then projection creates depth, which make it looks absolutely crazy realistic. Okay, projection create the depth. As you can see, depth is also there. Then our brain automatically connects the dot, and it looks like a 3D cube. But in real, it is just some points, and it is just flip book which you are just rotating. Okay, and math is used, and math is coming here. The math is playing the part of an artist. So that's the thing. I'm gonna quit this thing now. No. And yeah, for this thing, if you don't understanding what you can do, you can go on your paper. I'm not gonna do that thing. Just draw some points, and you can just connect it slightly with the pencil, and then you will understand. Okay, so what is the final thing we understand? Cube, Rubik's cube stickers, or each part of the Rubik's cube is points. Edge of a Rubik's cube are the line connecting stickers along xy rotation. XYZ rotation is like a spin cube smoothly. Loops fill the spaces, and perspective, far points look smaller. That's it. Okay, now no. What more thing you can do here is that first let's open my video, and I'm gonna again tell you that how code one. Okay, so let's again opening the video. One more thing which we can do is like we can draw wait a minute. One more thing which we can do is like we can draw. Wait, if I am able to draw it, we can draw this thing. And this thing I have already told you. Here you can from 0 to -8, and here also from 0 to -8, and fill every row. 0 to -8, 0 to -0 to -0 to -8, and here you have column, you have to fill only one time. And of course, if you are filling like this, automatically the column will also be filled. And these are points. So what you can do, you can go to any one point and label it. So this is the practice you can do on the paper for more understanding. And yeah, so now yeah, this is basically everything, and congratulations. Okay, congratulations, you have already know about the 3D coordinates and axis, cube faces and filled axis, why loops are necessary, rotation with sin, projecting 3D into 2D, how spinning a cube is built with point. Okay, so you have just learned the math behind the 3D graphics, the same math that video game uses. If you grab a Rubik's cube and follow along, it will make more sense. So take the Rubik's cube and follow, and yeah, that's the thing. Okay, so yep, now we are gonna go to our main code, and I'm gonna explain each line. Okay, each line of that code properly. Like I'm gonna do dry run each line one by one. Okay, so yeah, let's go. Yo, what's up guys? Now we are on our computer screen. Now let's understand this code more properly. I'm gonna use pen and paper also, so you understand it better. Sorry. So let's go, and yeah. So guys, this is a line by line thing which we are gonna understand. I think this should be okay. I'm gonna link this code in background also. There is no distortion. Actually, before I made, there was lot of distortion in my code, but now there is no distortion. So I'm gonna give this code a link down also, so you can download it from there. Okay, download it from there. So let's understand this thing. What is this tool doing? Okay, in quick recap, we understand this thing. This is width and height. So we are basically telling JavaScript, hey, this is how big our screen is in characters. So width means that horizontal line can have 80 dots. Think of it's like 80 columns. Okay, 80 columns, yeah. And the 40 means vertical line can have 40 dots. That's 40 rows. Now you will be like, hey, rows are horizontal. See, this in this case this is happening. It is very basic thing. If you know how to make tables in HTML, you would understand this thing. So this is very basic thing. This is our row column. This is our column. We all know. So for example, let's give them a name: C1, C2, C3, C4, C5. This is our rows. You know, we know that thing. R1, R2, R3, R4. Yeah. Okay. So now, if I wanna go, I wanna see, for example, if I wanna color, yeah. So for example, if I wanna go for color from R, if I wanna do coloring from this row, this two, from this column. So what I will select R1, R1, every point. See, everywhere is a point. Do not think that this whole line is R1. R, these are single points. Okay. So if I want to color this one, I will select R1 to R1, 2, 3, 4, R4 to color this column. And for example, if I want to color it horizontally, I will select C1 to C C5, C5, C1 to C5. Okay, C1 to C5, C1 to C5. To color horizontally, and to color vertically we will use row. So that is basically we are doing opposite things. Okay, nothing is simple. Now imagine a piece of graph paper with 80 squares and 40 squares. 80 squares cross 40 squares down. Exactly, that is what we are doing. And also the terminal cannot understand. Remember, this is the main important point which I'm gonna tell you. Terminal cannot understand the under, terminal cannot 3D. Okay, terminal cannot understand 3D. That's why it can only print characters. So this is the basically meaning of this thing. Okay. And more things like if width was smaller, cube looks tiny. If bigger, cube can be bigger. And yeah, that's the thing. And also width and help to center the cube also. Yeah. Okay, this is the thing basically. Now let's move to screen buffers. Screen buffers. Okay, screen buffers. It is very interesting topic. Gonna go to screen buffers. Okay, it's a very interesting topic. A screen buffer is a dedicated area of frame that stores pixel and can represent a display. Okay, so basically we are gonna store the screen at the depth. Okay, what character in our code we are also using storing thing. Okay, we are using like screen. This stores like what character is drawn at each position on the screen, and depth will tell us that that will store that how far is a point from the camera, like the distance, which is z-axis. Now we need depth because closer points hide farther points. Okay, and this is the thing which we use in high no, sorry, triple A games. Okay, lightning is basically depend on these things also, that far, if it is far, which type of lightning would be there, if it is close, which type of lightning would be there. And screen is like a paper, and depth is like a 3D ruling measuring distance. Okay, so we are, that's the thing, it is just storing that thing. Now these are, what are these are rotational angles, angle around and rotational angle around y, which I have already told you in before, so no need, but I'm gonna again tell you in so that these angles determine that how a cube spin around y-axis and the y-axis and the x-axis. Okay, angle x rotation from like left right, like tilting your head, nodding your head, and angle y is, angle x is nodding your head, and angle y is the rotation of front and back, like shaking the head no. Yeah, that's the thing. That's the thing. Both angles are of course zero, initially zero. So angle, this angle basically, it will change the which points are higher or lower on the screen, and this angle will tell us that which points appear left or right. Together they make a cube spin, and there, and because of that, a 3D thing is formed. Okay, a 3D effect is formed. Okay, a 3D effect is formed. Now from this large number, this rotate function. Okay, so I have already told you this function takes 3 points. Okay, coordinates a dot of the sticker, top, for example, top front left of a Rubik's cube, which I have already shown you, top, which I hope that you remember. Okay, let's say this is the Rubik's cube. So this point was minus x minus y and minus z. Yeah, that point was that. So like that only, it will take 3 points coordinate. Okay, now what if the function will calculate new position, this function will calculate the new position after rotation. So each sticker must rotate to make the cube spin. So with so yeah, that's the thing. And that it is using math, cos and sin for doing that thing. Okay, so now understand this thing more. Rotation around x-axis, in which just y and z will change, and rotation around y-axis, in which z and z and x will change. Okay, so these point here, this point, these two lines, this rotate the cube around x axis, and cos and sin are the trigonometry functions, and they are supposed to tell the function position on a cube. Before, on the explanation when we have already talked about it. And like y1 is a new position of y after rotation, z1 is the new position of z after rotation, then that thing. And yeah, small changes in the angle x, this is angle x. So if there is a small changes, for example plus 0.3, so this will make the point move gradually, and it will make the smooth effect. Okay, so that's why here we are taking angle x. Okay, now no, around this are the rotation around y-axis, and exactly that is the same thing, only x and z change, y remains same, and z2 is the new opposite coordinate, and x2 is also a new coordinate. Every point moves in a 3D space. Without this, the cube will tilt but not spin side to side, and like this thing only. Okay, we have understand this thing now. No. What we need to understand is that this return our new coordinates. As you can see here, these are the rotated point. Okay, and it will give, now these are the updated. in each frame. Okay, like a flip book, if you are drawing a flip book, each frame you have to draw, okay, like that only. And these coordinates go to draw point. You understanding how easy it is if you once understand these coordinates. Here we draw point, here we, and how fast the function is working. Okay, like each second it is very fast function, very fast code it is. So these are going inside these thing. Okay, and from there it will draw a point, because of course, as you can see, draw point is the name of the function. And every sticker rotates simultaneously. Okay, these are the thing. Now let's go to draw function. This is the one of the most important function, and yeah, this is very short code only, not that much big, only 90 line. It would be 80 line. There are some spaces also in between. Okay, now this function start with taking the rotated point. Okay, rotated point, it takes the rotated point in char is a character, like what we saw on the screen. For example, at the rate, dollar sign, star sign, we are using that. As you can see, if I go to the code thing, if I will go here, we are using that signs only, plus sign. Okay, so char is just the character. Okay, now think is like Rubik's cube. Okay, Rubik's cube sticker is a single character in a terminal. Okay, so that's the way I'm using Rubik's cube, because it is the best example of explaining this thing. Okay, so terminal is flat, so that's why we use math to make 3D look 3D. And every frame we call this for thousands of point to draw the whole cube. Okay, every frame we call this thing for thousand of point to draw the whole cube. And without this, the cube will not appear on the screen. And this is the main core of visualizing 3D into terminal. You understand this thing? Okay, now there is one more thing, these two lines. Okay, I'm highlighting which lines I'm explaining. So distance is like, pretend this, how far the camera is from the cube. Scale determines how big the point looks based on the z coordinates. And point closer appear bigger, and a point farther appear smaller. This we all know. This is the perspective projection, which diagram I have already shown you. And now this, what is the meaning of this? Scale is equal to distance by distance plus z. See, this is a math trick for uh, depth trick. This is basically the depth trick. Okay, if z increases, point goes farther, and if z decreases, point come closer. This is the basically what it is doing. Okay, this is the basic thing what this is doing. If the point is farther, I'm again telling you, if the point is if z increase, the point is farther. Okay, further. And the if z decreases, the point is closer, and the scale will increase. Point will look more big. Okay, now let's understand these two things. They are also very important. Okay, we convert 3D xy into 2D screen positions. Okay, so width by 2 create a center horizontally, and width by height by 2 will center vertically. Now we'll multiply by scale. We'll multiply both by scale, but in the x case, multiply both by scale, and we also then also multiply by scale, then also multiply it for 2 for the x aspect ratio. Okay, as I have written here, multiply it by 2 for the aspect ratio. In this case, we are not gonna do that thing. And math dot floor, we all know that they are integer, do not come in uh, decimals. And screen x is the column number. In short, screen x is the column number, and screen y is the row number. Okay, screen y is the row number. Now uh, example, the top left sticker, I'm taking a lot of example of it. Okay, if we are drawing it on a paper, we are gonna do it, the coordinate would be 0 0 for the top left sticker, for the top left sticker on a Rubik's cube. We are not taking z here. If we take the z, then one more, then we have written that, but now it is on a paper, not on cube. It now we are thinking 2D. Okay, and the center sticker will goes to this thing. Remember, the center sticker will go to this thing, the center coordinate. And this is how we map the 3D points in the terminal grid. Now, what? Index. These are the index for arrays. Okay, index is a position in a 1D array representing the screen. Screen is flat 1D, but we think of it as a 2D grid. Okay, screen is also flat, it is also 1D, but we can think it as a form of 2D if we add x, y, and z, x, y, and z. Okay, multiply a screen y well with number of arrows column in the current row, and add c. This thing what we are doing, this thing, see. Now we will multiply screen y by to width. We will multiply it, the number of full rows above the current row. Okay, this will give that, and then we will add a screen x, which will give the column in the current row. So the basically the coordinates. So like you can think of it writing a letter row by row in a notebook. Okay, now using index we can store what character goes where. For example, middle of a screen, as screen x is equal to 40 and screen y will be 20, then index would be 40 plus 20 into 80, which would be 1640. 16. Wait a minute. uh, for example, screen y is 40. Screen y is 40, then we will plus it with 20. 20 multiplied by 80, it would be 4800. Wait, I have done around 4800. It is not. Okay. Wait, we are not following the board mass, man. We are not following the board mass. 20 into 80 plus 40, and this is the correct thing. 1640. Okay, board mass was not there. I don't know why. So yeah, 1640. It would be terminal prints. Okay, the answer would be 1640, the index answer. Okay, now the terminal prints the array in sequentially row by row. Okay, the terminal prints array sequentially row by row, and that matches our to 1D array. Okay, so this is like making drawing thousand of point very efficiently. Now we will do a check also, depth check. So basic this is basically the depth check. Okay, so the first line basically means this one, that like insert point is inside screen, we are this line basically mean. And the second after and this means that point is closer than anything already there. If yes, update the depth, and update the character also, which will be our new character. So for example, yeah, that's the thing. And we can think it also like a stack of boxes. Topmost box would be visible. Okay, think what I'm saying. Okay, without depth, cube looks see-through, and all stickers would be visible at once. This is why cube looks solid in terminal, because of this thing only. Every frame is like a depth. Every frame a depth is reset and the point are recalculated every frame. So we'll get a pure logical effect, 3D illusion. Now this is our last thing, which is draw function. Okay, now this is a very big function, this draw thing. Okay, now see, I'm gonna explain. is like every frame we start fresh, so that's why old points are removed and new points are recalculated. Here the screen array hold what character is shown at each position. Okay, this screen array and this and dot fill means that start with blank spaces for all position, later we will fill the spaces. Now what is this depth? Depth is how will hold how far the point each point is at a position. Now fill 999 when we this is the initialize all depths far away, the point can overwrite. So at first the depth is very far, so yeah, this is the basic default thing. Okay, so without this thing, like previous frame would overlap with the current frame. Okay, previous frame with overlap with the current frame. Okay, previous now. Uh, Also the like this is the reason why the our cube looks solid, not transparent. This is the basic reason. Now what is this size and the step? Okay. So size is half length of a cube along the each axis. Cube goes from minus size to minus plus size. Okay, remember this thing. Cube goes from minus size. Wait a minute. Wait a minute. From minus size to plus size. What does this mean? This is basically meaning the cube length is 8. This is our line of x-axis. If the cube length is 8, it would be minus 8 and it would be plus 8, and that's why we are saying this minus size to plus size. This is the basically this is what it is saying. And yeah, and now what is step is the distance between points. Smaller means more point and the smoother cube, more smoother cube. Okay, and larger step means fewer point and cube looks blocky. So with size so basically from these two things we create a lot of points of a dense for a dense cube. We can also increase this so the points will be more small and the cube will look more solid, but that creates a kind of distortion in the rotation, and that's why. Okay, okay. And I and j in a loop moves through this grid. Okay, I and j's who move doing their work also, so they are basically printing points. Okay, this control how detailed and filled the cube appears, how detailed and the full. See, every function is some function. This function will just give the rotation point, and this function will draw, that function will draw a point. Okay, and this function will basically that it will not draw. This function will give also calculation. They all are doing calculation and this function is mainly drawing. Now what is outer here? Like there are loops, we say nested loops go through go through every coordinate on the face. We already know that left right up down outer. This is the outer loop which rows of a sticker horizontally. Okay, horizontally, and this is the column vertically, and all 6 faces are drawn inside these loops. And without loops you would have only 8 corners, no filled space, and it would look like skeleton. This is why this is very crucial. Now we'll go down. Front face, back face, left face, right face, top face, bottom face. Front face, z would be my z here. Z would be fixed, as you can see here. Z is fixed. Front, because the z is minus, because at front z is minus, at back it is plus, and these two are changing. See the size, the coordinate in the sequence you see xyz, so they are ij means they are changing. This is not changing. In the back face these two are same. In this thing x is not changing, and this is changing. uh, X is changing, and in the right face also, but with opposite a positive in top. This thing y is changing, y is not changing. Okay, and in back face also that thing all. Yeah, okay. That thing is only that thing is only there. Okay, and I have already explained this thing back in my video. Now console dot clear back face. Okay, front face. One face I'm gonna explain you well. Front face one more time. So front face, I moves x y, left right, and j moves up down. Call rotate, it will call rotate. So like compute new 3 coordinates, draw point, project rotated point to terminal. This is basically the character. Okay, color character. And uh, like uh, rotation, spin this stickers or character around the axis, and the perspective makes near character appear bigger. Okay, now same thing for back, front, left, right, top, down. Now this is the last part. Okay, here we will clear the terminal. Okay, clear, erase the previous frame. This is basically the text. This will give the this part, basically this after M. This is for the yellow text. This code is for bold and bright in the terminal. So this will make the cube appear visually more appealing. And each frame prints new position. That's we all know. That is what we all know. And yeah, now building output string. Okay, this is the last part. Building output string. Wait a minute. Yeah, this is the last part. Building output is string. Output is the final string to print in the terminal loop. Go through every character and add character. This is basically is going through every character and adding character to the output. Every with character, new line. Okay, every with character is, we all know it. In HTML we have learned this, that this help us to new line. We have learned break line, this for new line. And it is like yeah, now it will also matches the 1D array to the terminal. Now terminal prints string, then cube will appear. If this would be not there, the cube will be printed in a single line. So this is for new line. Okay, after one, like it is like writing or drawing the cube row by row, like drawing like this, 1 2 3 4, like this boxes. Then new line will start, then again drawing, then new line start. If the n was, if that new line code would be not there, then the cube will be printed like this thing. Okay, that thing, the cube will be printed like that. Then we will console dot, this is the final part. Okay, this will print that thing. See, console dot log is nothing, nowhere. Here it is printing everything. Above is the just calculation. Console.log will be the output. Then this, what is the meaning of this thing? This will reset the terminal color to default, ensure next character prints normally. Okay, so this is basically used to avoid color reads above across the frames. Okay, this will allow us for doing that. If you remove it also, this is not just a good practice. I have seen one code on GitHub of this spinning cube and it was there, so I just copied it from there and pasted here. I also don't know what this mean. And now what is this last thing? This small increment in the rotation. So the cube, I have already told you in back, the cube will rotate here from in, yeah, the cube will rotate slowly. The cube will rotate slowly, a small increment. Angle axis, spin around horizontal axis, spin around vertical axis. So that's the thing. This small rotation on a cube, increment, and this is the basically the motion logic for our spinning cube. Without angle change, the cube would be static. Okay, so every frame angle updates and cube spins continuously. Now, what is the summary of this draw? The draw basically reset the depth and the screen and depth. Look through points on all 6 faces.
rotate each point, draw each point with a draw point function, clear terminate, set color, build output string row by row, print cube, reset color, update rotation angles for next. And also I don't know the real meaning of this, so I was like reset formatting, but I don't know why we are using this. I have just copied this because yeah, it was written in the GitHub readme that you should use this thing for reset the formatting and avoiding the color uh, bleeding. Now what is this at last set interval? There is no clear interval, so only control plus C we can remove. Stop this. So this basically means that it will execute this draw function repeatedly every 50 milliseconds. I hope you like this video. If you like this video, please subscribe, and next topic it would be related to physics. Till then, peace and subscribe.